All right, so this question talks about a block on a horizontal surface being pulled across, which seems rather simple. But because there's also an applied force vertically, this problem has a few more tricks to it. The biggest thing, though, is that we don't know whether this block moves or not. We're asked to find the frictional force, but we're not told in each situation whether it moves. And so that's the first thing we're going to have to do. I pulled this slide from an earlier video to remind you that there are sort of three ways that we need to think about friction when static friction is involved. If an object is not moving at all, we need to decide whether it is in this situation where it's moving, but it's not at the point where it's using the maximum amount of static friction, whether the object is about to move, and so that the frictional force is the maximum value, mu sub s times the normal force, or whether the object actually moves, and then we're just switching to kinetic. And so as we look at this question, we're going to have to first decide which of these three categories the block is in for each situation. So in the first situation, we have a force P of 8 that is up, and we have a force that's being applied horizontally in all situations of 6 newtons. And then the weight of the block is given to us as 25 newtons. So in all situations, we would use 25 down. Of course, that's not balanced out because there is a frictional force. That's what I'm trying to find. And then there's going to have to be some sort of normal force as well. And the key thing in order to figure out whether this object moves or not is to figure out what is the maximum value of static friction and how does that compare to the pulling force of 6 newtons. So what we'll do is we'll say that the forces are going to have to be balanced in the y direction vertically, and so that means that the normal force plus 8 would equal 25, or that the normal force would be 17. And from that I can determine the maximum value of static friction. That can be found by using mu sub s times the normal force. So 0.4 times 17, so that is 68 newtons. I'm sorry, 6.8 newtons. Let's write that again here. 6.8 newtons. All right, so that's not the actual value of friction. That is the maximum possible value of friction. But we pull with 6 newtons, and so if we pull with 6, then all the way up to 6 newtons, it's not going to move. Or all the way up to 6.8 newtons, it's not going to move. So with 6 newtons of force pulling forward, then 6 newtons of force must be pulling backwards. And so in this first situation, for part A, the frictional force just balances out the 6 newtons of force pulling forward. Now in the second situation, we have a lot of the same information. We still have our weight of 25 downwards. We still have a forward pull of 6 newtons. We still have some sort of normal force, but I don't know what it is. And in this case, we are pulling upwards with 15 newtons. Okay. So again, I want to see whether that change to the upward force, whether that is enough to allow this block to break free. So I'll say that the normal force plus 15 would equal 25, and so my normal force would be only 10 newtons. And so when I calculate that maximum friction, I'm going to take my value of mu 0.4 times 10, and that is only only 4 newtons. All right, that's the biggest that friction can be. If I pull with 1 newton, it can pull back with 1. If I pull with 3.5 newtons, it can pull back with 3.5. But I am pulling with 6 newtons of force. That's too much for friction to handle. So what happens is all of this information is not valid because it moves. And so this is no longer the correct information to be working from. So what I have to do is, because it moves, I switch to frictional force equals the kinetic value of mu times normal. And so since that is 0.25 times, now my normal force doesn't change, it's still 10 newtons. Then my frictional force is going to be 2.5 newtons. All right, if you're kind of getting this, I'd suggest you shut the video off and try part C by yourself and see if you can figure it out. But I'm going to go ahead and solve it right now. So 6 newtons forward still, 25 down, that's my weight, that doesn't change no matter what I'm doing. And I'm going to need to know the normal force so I can find the maximum value of static friction. And what I know now is that P is somewhere in between my two values, 11 newtons. So I have to figure out what happens here, whether that provides enough normal force to provide enough friction to keep this thing from moving. So my forces in the y direction, normal force plus 11 is equal to 25. There we go, 20, yeah, I swear that's a 25. 25, there we go. And our normal force is then 14 newtons. All right, so then what we'll do is we'll calculate that maximum value of friction by using mu sub s, 0.4, times our 14 newtons. I'm just trying to figure out, does it move or doesn't it move? And let's see, so that comes out to be 5.6 newtons. Okay, so the biggest that this force right here can be is 5.6, but I'm pulling with 6 newtons. So this object moves, so I got to use kinetic. The kinetic frictional force is mu sub k times the normal force. So that's back to using the 0.25. I can't just use the same value that I calculated in part B because my normal force changed. So now we're at 14 newtons. And that one is, I'm going to grab my calculator, that is 3.5 newtons of force. There you go. So key thing with static friction is if you're not told whether the object moves or not, you have to first figure out which is the case.